On the 12th day of Christmas, Mr. Ing gave to me 12 perfect scores, 11 lessons learning, 10 steps for factoring 9.
Hi guys, I want to do an introductory video for C0 and D0. Steps for writing radical transformations from a graph, or if you're given two equations. Now the very first thing you want to do is make observations. Write the parent function. Let's write that. That's super helpful. Write the parent function. So you can see the differences. What is that? This big thing. Write this down every single time for the problem when you get the equation for C0 or for the C problems, and for D you're going to kind of do the similar thing, is you're going to identify the letters. So you're going to take the characteristics and you're going to try to make them letters. Remember, A and B will help you flip it across the A flips it across the x-axis, and the B, if it's negative, goes across the y-axis. B, perform stretching and shrinking next. So those are the factors of A and B. And then perform horizontal and vertical shifts last. This is the adding and subtracting of the C and D values. Now if you need to, you can always go back and check your coordinates. And basically your observations and your graphs can also match each other. And so this is how you perform transformations, either looking at how you're given two equations, or if you're given a description and the parent graph, and you had to write an equation. Describe how each graph represented by f of x will be transformed to create the graph represented by g of x. I highlighted the word describe because we actually have to use our words. So here's kind of like a real life example. Let's pretend f of x is when you left before COVID and we had to stay at home for distance learning. And then let's just say I see you again a year later. You're gonna look a little bit different, right? I'm gonna look a little bit different. So we just need to compare. Well, how do you compare? I said, let's write the parent with all the letters, which is, didn't write it up here, but now I can. It's too long. Okay, so then you can just go through, maybe a highlighter might be helpful. Okay, everything in front is the same. They all have a square root. All of the B value, which is in front, let me do a different color. The B value, which is a 1. Okay, then a C value, that's just a negative 2, but not important. Okay, the most important one is that this one has nothing, but this one has 5, so D is equal to 5. The question is, what is D? If you look back at your intro video in your characteristics, we actually did this in part A and B. The characteristics of this one is that D equals 5 is just that the graph is shifted up 5 units. So basically my observation is that D is different, taking on the letter and putting it into a sentence. Here in C2, I noticed that pretty much everything looks the same. Okay, the F and the G are going to be, they're just different functions. It's kind of like when I lined up two twins together. There might be something slightly different about one than the other. So they both have an X, they both have an equal sign, they both have a square root, and they both have an X. But the only thing that's different is this negative sign. And if you write it, the parent, what I'm going to notice is that this negative sign is actually your B value. Okay, so let me write that. What does it mean that your B value is -1 or negative or less than 0? if you look back at our intro video for A, B, and C, you'll notice that some of the characteristics in our transformations is that when this is negative, that means that the graph of f of x will be reflected over the, remember the negative sign is the inside of the radical, that's the y-axis, to create g of x. So the big idea is, what I notice is that b is a negative one, and the characteristic I put in words is that it's reflected over the y-axis. Here, I notice that f and g look pretty much the same. They have an x. They have both a -1 inside the radical, but the only thing that's different here is this 3. And this 3 is on the outside. Let's write that, outside. What else do we notice? It's to the left. If you needed to, you can write the parent function. And you'll notice that it's on the outside, so your a value is essentially 3. Okay, if you look back at your notes, this number is greater than 1. So this is basically a vertical stretch. By a factor of 3. Okay? So make some observations. Is it inside or outside? And then look at your characteristics and you can identify it. Try to use some colors here. I see that they both have a negative sign. They both only have an X on the inside. Okay, here's the one that's going to be different here for C4. And of course, they did it wrong. This was supposed to be a 1. Okay, so what's the difference here in green is your D value. Okay, so pay attention now. I'm going to say your D value is 5. Where did I get 5 from? Well, to go from -1 to a +4, you're going to have to add 5. Why? -1 plus 5 equals 4. So, what is the D value? It's to the right of the square root. It's on the outside. D value is going up or down. This is positive, so it's going to be shifted up 5 units. You're supposed to describe in words, and if I notice this one actually has 2 things going on. This one has a 7, and then this one has a 4. So I want to teach you guys visually, and then you guys can just see it algebraically. So x minus 7, remember my silly phrase, add to x, go west. Do you see a adding here? So you're not going west or left, you're going towards the right. So this is, your graph's gonna look something like this, okay? And then if you do the green one, at 4, how did you get there? Well, you went left 3. So left 3, essentially that is a C that is -3. Okay? So let's write that. Shifted left 3 units. Okay, let's do the same thing now with let's just say the parent graph here at +2 looks like this, and then let's take a different color we haven't used. Let's use my favorite color, and this would be purple. Okay, this one's at -3. So again, you're going from 2 to -3. Well, what's the difference there? You're going what? Down 5. So D equals -5. That means you're also being shifted down 5 units. Okay, so the visual helps, And let me show you guys the algebraic. This might help too. The algebraic here is you're starting at 4, and then you're saying what's the difference at 7. That would be a difference of -3. And then this one, you would do the same thing. It would be 2, -3. And the difference of 2, that would give you a -5. And that's how you get -5 there. I have to describe this in words, and I'm just going to make some observations. 6 is the same. The plus sign is the same. X is the same. And something that's different here is this one has no number in front, and this one has a 1/2. So if you wrote the parent, now this is a cube root, bx minus c plus d. Okay, we just said that the 6 stays the same. So essentially we're saying that you don't need the d, c, and b, it's the a value. The a value is 1/2. Okay, if you look at your notes, the a value talks about a vertical compression. Like if you wear a compression sleeve, it's helping all your big muscles stay inside. And then the other way around is a stretch, right? You're tired, you put your arms up, that's a stretch. So an A equals 1/2 is a vertical compression by a factor of 1/2. All right, C7, let's make some observations. They both have a 5 here. They both have an x, but one thing I notice is that this one has g of x has a negative sign inside. If I quickly write out the parent, the a times the cube root of b times x minus c plus d. And if you notice what I kind of did here, I kind of wrote it right above it. So, there's your d value. This one has no c value. The a value is just 1 because there's no number out there. And then our b value is -1. Okay, do you see how that's to the left of the x there? Let's write that. B equals -1. So if you look back at your notes, what happens when your b value is negative or the negative's an inside, you have basically what? The graph of f of x would be reflected over the y-axis to create g of x. Okay, so that's what a b equals -1 does for C7. And now just thinking you can also graph these two functions, f of x and g of x, and then you can see the transformation. But the goal is you're trying to see the transformations without graphing. You're just kind of doing algebraically or with the letters. How can we describe what happens from f to g? All right, they both have this x. Okay, now this one has a 2, but this one has an 8. Okay, notice how those are inside the radical. So your choices are the letters. If you don't remember that, you can just write out the parent. Oops, that's supposed to be a minus c plus d. Okay, so it's in the inside. So it's not a, it's not d. And it's to the left of the x. So this would be a b value. Okay, pay attention now. My b value, let's make this green. Use green, whoops. How do you go from 2 to 4? 2 to 4. How do you go from 2 to 8? Well, you have to multiply it by 4. Okay, so my b value is equal to 4. My b value is equal to 4. And if you look, you have a horizontal compression or a stretch. Okay, and because remember the factor is the absolute value of 1 over b. So if you look back at your notes, when that value so let's go ahead and write that. So we're going to have a, let me double check. So we're going to have a horizontal compression by a factor of 1/4. Okay, how do I know it to be 1/4? Well, if you take this value and put it in for b, you're going to get the absolute value of 1/4, which is 1/4. Okay, so that number, this factor here is less than 1, so that's why it's a compression. Let me show it to you one other way by using a table of values. Again, I'm trying not to use the graph. Okay, so if I did the blue here with a table, 2 times some number x, so for x, I'm going to put 4. Why did I pick 4? Because if I put 4 times 2 is 8, and the cube root of 8 is 2, right? And then if I chose this one to be green, and I want to choose some number so that it's going to be a cube root. So if I put 1 times 8 is 8, cube root of 8 is 2. What's the difference between the two table of values is from 4 to 1. Well, how do you go from 4 to 1? You multiply it by a factor of 1/4, which is the factor we just got. And that kind of goes back to that formula 1 over bx to the y. Okay, and that's how you know it is a horizontal compression.
Math is my favorite subject and a very challenging class. And if you